because that's what he does. I did my best to draw it, it's not very good, but I think you get the idea. All right, so yesterday you had some time to think about it. What are you doing, Vampire? We have class.
Oh, sorry. What?
No, you can leave the door open, but don't socialize.
Oh, okay.
How about, what were you doing yesterday? When you had time in class to work on this, where did you start? Did you have a starting point?
Just like found the paper.
Me and Perry started with the linear.
Okay, so some of them then and partners figured out that two of these guys are linear, all right? Two of them are linear, so that would be the red one and the black one. And the red and black equations would be here and here, G and J. Would you agree with that?
Yeah.
Now, when you look at your lines, your red one and your black one, it's pretty clear that one of them has a positive slope and one of them has a negative slope. Well, this guy right here has a slope of 3. So that has to be your red line. Would everybody agree with that? That this is a red line? And since the red line contains the point 2, 8, we know that 8 equals E plus 3 times 2. So E must be 2. So later on down the page, you're going to have to find all those values anyway. So I just did it now, so I know E is 2. Okay, that means that the black line must be G, right? And again, we know that it contains the point 2, 8. So 8 equals 18 plus 2B. So it looks like B is -5. Negative, as we knew it would be, and it turns out to be -5. I think that's a great way to start with the two that you know are linear. Now the other 3 are exponential. What do you notice about them? Tyler, did you notice anything?
What I was going to say is they all, or 2 of them meet at the same point.
Down here?
Yeah, down there and then one up there.
Oh, up here, yeah.
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 Yeah, so you can mark those down as points that you can use later to figure out.
Okay,
Yeah.
all right. So what is this point right here?
0, 2.
And he knows that, you guys, because isn't that point on the red line? That is the y-intercept of the red line. And the y-intercept of the red line is 2. And then similarly, this is the y-intercept of the black line. And the y-intercept of the black line is 18. Those might come in handy. Look at my green and my blue, and then look at my purple. The green and the blue are both examples of growth. The purple is decay. So if I look at my equations, isn't W a growth? And isn't K a growth? So the decay equation, which is the purple one, must be this right here. Would you agree with that? And the purple one, as Tyler pointed out, has an initial value of 18. So C has to be 18. Remember, the initial value means X is 0. And then again, we have this point. So 8 equals 18 times times d squared. So 8/18, which is 4/9, equals d squared, so it looks like d is 2/3. Which, as you suspected, less than 1, that's a decay equation. All right. So now what have I got? Green and blue. Any idea here?
You could say that because like F times the K is probably blue because it's like, it gets bigger faster.
Ah. She says it gets smaller faster and it gets bigger faster. Think about this for a second. What happens if you square 3? 3 squared,
9.
yeah, but compared to 2 squared. And 4 squared is bigger yet, right? So the bigger the base, the quicker it's gonna grow. So she says, looking at my picture, or maybe looking at that picture would be better, but looking at my picture, it looks like the blue one is getting bigger, faster. So that's my blue equation. And what do I know about my blue equation? Well, don't I know that if I put in 8 for y and 2 for x, it's on that curve. So it looks like f must be 8/9. And that leaves me with green. I know my initial value of the green equation is 2. So A has to be 2. And that's it. So now down at the bottom, the last question said, find A, B, C, D, and all that. We've done that. We have them all now. All right, so is that okay with everybody? You follow all that? All right, least to greatest. W are all of the functions of 1. All of our functions of 1. Now, if this is 2, then isn't 1 like right here? So littlest, can't we just go right up the line? So blue is littlest, and then green, and then red, and then purple, and then black. Does that make sense to you? What about 100? Function values at 100. Well, I'm not, clearly I can't get out to 100, but is everything gonna just kind of continue on the path it's on? So I can really just look right here, and it's gonna be black, purple, red, green, blue. That blue one's shooting way high. Is that okay with everybody? All right, now what is K of 15 over K of 13? What's your thought on that? Can we find K of 15? K of 15 will be 8/9 times 3 to the 15th. I don't know what that is. That's going to be huge. And K of 13 is going to be 8/9 times 3 to the 13th. Just a minute. You're right. Just hang on. So can we cancel these? So we have 3 to the 15th over 3 to the 13th. What does that make? 3 squared, which is 9. All right, now Tyler says he's got a different thought. What's your thought, Tyler?
You just did it.
Okay.
We could, I mean, we didn't even need to know the values. We could have just F cancel 315, 313.
Here's the deal, kids. Isn't this is exponential. And what does that mean? That means we get from term to term by multiplying by 3, right? So if we have 3 to the 13th, and we're going to 3 to the 15th, don't we have to multiply by 3 2 extra times? And that makes 9. We can figure it out, we can do that, that's fine. But remember, they're separated by factors of 3. So if there's 2 steps you're going, then it's 2 factors of 3. All right, how about 5? It's kind of the same thing. J of 15 minus J of 13. Can we find J of 15? Yeah, that's easy. 47. And J of 13, 41. Wait a minute. Does that make sense? Yeah, because this sequence is arithmetic, or this thing is linear. And to go from step to step, we add 3. So if we are going from 15 to 13, doesn't it make sense this is going to be 6 more? Because we added 2 extra 3s to it? It makes sense? All right, and we already did 6. Everybody cool with that? Fun, fun, fun. All right, get out that review sheet that I gave you then. Yep, if you weren't here yesterday, go back and get it. No, you got this one yesterday. It says review topics 2 to 3. I think you got it yesterday.
I'm pretty sure we got it yesterday since it's not recent.
I think I handed it out yesterday.
I think you remember something.
All right.
Yeah.
Well, I have a bunch of papers I want to get handed out to you, get handed back. Because next class, we will be going over homework questions. So I want to get these homeworks back to you so you have a chance to look at them. And I'm going to take attendance. While I'm doing that, I want you and your partner to work on problem number 1. And if you get done with 1, go on to 2. Just keep going. I don't know how long it's going to take me to get these papers handed out. All right, so I have Bailey, Sue, Zamia, Charlize.
each other.
Get there.
In my head, I rewrote it like top to this.
Okay. I think I'm done. Yeah, like I said, take a look at those, we'll take care of any questions next time. All right, have you finished part one? Looks like it. What'd you do for number 1A? Arithmetic with a difference of -4. Right, your common difference, -4. How about B? Arithmetic with a common difference of 2/3. Everybody see that? How about C? Nothing. There's a pattern, you can find that, you can certainly continue the sequence if you wanted, but it is not arithmetic and it is not geometric. How about D? Geometric with a ratio of 1/2. How about E? Arithmetic with a difference of -1/2. And you could have done that, I'm not sure what you did, there's some options there. Could we have, just written out some terms? Yeah, but we also could have looked at it as 2 minus 1/2 n. And isn't that y equals mx plus b? So there's a slope or a common difference of -1/2. And what about F? Oh boy. What about F?
Geometric.
It's definitely geometric. And what's its ratio?
-1/2.
1/4? Why is the ratio 1/4?
Because it has the square in the end.
Yeah. You gotta pay attention to that. What you're really taking to the nth power is this, isn't it? Are any of those terms gonna come out negative? No,
Oh,
because you're raising it to the 2nth power, and that's always gonna be even. So your ratio is actually 1/4. Do you have a question? Yeah. Your ratio is actually 1/4. Is that okay with everyone? A little tricky. Yeah, that's my job. Mess you up however I can. All right, number 2, let's get these on the board. And because we're videoing, you have to stay on this board. So we'll have A over here, because I have a volunteer for A. Put B here in the middle. And C kind of over here. So volunteers, here we go. Thank you. Takes courage to volunteer. We love our volunteers. Hmm? I know. No, that red one doesn't work very well. Let me find you this thing. That one might work. This blue one works great.
You want me to draw the graph, please?
Huh?
You want me to draw the graph?
No, you don't need to just put down your work. We all have the graph. In number 2, the directions tell you it's arithmetic. Would you have known that just by looking at picture C? Yeah, because arithmetic is linear. So we knew that one.
What?
Oh, you guys made quick work of that. I love that everybody used a line strategy. Everybody found the slope and did point slope. That's fine. Don't have to do it that way, but that is a great strategy. You guys at your seat? I haven't checked the A sub 37 values. Are those all right? All right, okay. We all good on that, folks? Ready to turn the page? All right, number 3, now we've got all geometric. Let's spend some time on that and put those up on the board. You have these done? Okay. So if you feel like you've got a good answer for A or B or C,
Oh, yeah, so I am right. Y'all bet. It's all right. Or should I do C first? Wow. It's probably, it's just a negative. Oh, it's like, okay. It's just negative 1/3. Yeah, it's negative 1/3. First term. That. First term.
Yeah, just put it in.
I was gonna do B. Oh.
remember, there's always more than one way to do these problems, so don't worry. If yours doesn't look exactly like somebody else's, Just make sure your answer matches.
Did you get this for, G to the 12 on C?
Yeah.
Yeah.
I mean, think about that, it's what we talked about the other day. That's decay, but you know how fast things grow? Well, they decay just as fast.
Beautiful. There we go.
All right, we're C fans, let's go. Why are we not doing C? A little bit wonky, but I think you can do it.
Hey, I'll be better about my hands. Yeah, please. Gonna make it as bad as I possibly can.
Now, letter B, we got a little bit creative on, it's fine. But yours may not look like that, it probably doesn't. But just check to see if your G of 12 is the same as his G of 12, or G sub 12, G sub 12. See if it's the same thing. I happen to agree with all of these, so if we're wrong, we're both wrong, because I think they look good. Let's talk about this one. First of all, I'm gonna go ahead and change that to an N. Okay? So they told us that the first term, that corresponds to 1, 6, that's the first term is 6. So in my formula, I need the first term and I need the common ratio. They gave me both of them. So I think that's absolutely beautiful. And then to find G sub 12, we just put 12 in there, type it in our calculator, and we get that answer. Is that okay with everyone? Now I want to just mention, just another thing, but geometric sequences correspond to exponential functions, right? When you write the equation of an exponential function, your exponent is x. Not x minus 1 or something, or x minus 2, it's x. This guy right here is your initial value. The initial value is the y-intercept, 0, comma. So if we wanted to use that format, we know our first term is 6. We'd have to back up one more to get the 0th term. So since you know your ratio is -2, that means we keep multiplying by -2. So if I went backwards, I would divide. So my 0th term, my initial value, is -3 times -2dx. So this would be an alternative, oops, no, not that. This would be an alternative formula And it's just fine. It gives you exactly the same answers. This is fine, totally fine. So is this. Now, are we good on that one? This one, okay, when I write a geometric sequence, ideally, I have my first term and my common ratio. He figured out by what was given, so the second term was 1 and the fifth term was 27. So he figured out that I had to do 3 multiplications to get from 1 to 27. 1 times 27. To accomplish that, I had to do it in 3 steps. So therefore, R has to be 3. I'm going to multiply by 3, by 3, by 3. That's the second term. Normally, what we've been doing is we've been backing up 1 to get the actual first term. So if my ratio is 3, then my actual first term would be 1/3. Would y'all agree with that? So using this formula, your nth term will be 1/3 times 3 to the n minus 1. Now, he said, I don't want to do that. I want to use my first term. So that means instead of backing up my exponent 1, I have to back up my exponent 2. Because I'm technically using my second term to get the ball rolling. The first term backs it up 1. So the second term would have to back it up 2. Remember, the initial value, your initial value here, backs it up 0. That's your plain n. So that would be 1/9. So I have this one, he has this one, and another one would be 1/9 times 3 to the nth. All of those are perfectly fine formulas. It just depends what flips your switch when you look at the problem. You okay with that? Clever. All right, what's happening here? We have a picture, and they kind of look like they're all over. But you noticed your first term was 1/9. What was your second one?
2 -3.
Yeah.
I should put that.
So to get from term to term, it looks like we're multiplying. Remember, this is geometric. We're multiplying by -1/3. So he said 9 times -1/3 to the n minus first. Beautiful. He was a little concerned when he found the 12th term because that number came out so small. But just like geometric sequences grow really, really fast, they shrink really, really fast too. So that isn't surprising. Somebody this morning had a great question. They said, Mrs. Ford, you keep telling us that geometric sequences are exponential functions, or that they're tied together, but that sure doesn't look exponential. That picture doesn't look exponential. Can you explain that? What's the deal?
It's the
The negative, yeah. When you write the equation of an exponential function, we're dealing with exponential functions, then b has to be bigger than 0. Now, in reality, can b be less than 0? Sure, we got an example right there. But when that happens, you don't get this nice smooth curve. you get things bouncing up and down from positive to negative. So in general, when you're dealing with sequences, which is what he's dealing with, I don't care what you put in there, you have to put whatever you want in there. But if you're dealing with an exponential function, if you are writing an actual function, f of x equals, then you wanna have your b as a positive number. Okay? That's the discrepancy. All right, number 4, here we go, we're gonna do a couple more. Number 4. We've done lots of these, we have to be able to do them, okay? It's the first thing your beady little eyes are checking out. James? What? Let's turn on our beady little ears. Let's open up our beady little eyes. What is the first thing you look at when you look at this table of values? What is happening to x? What is happening to x? Right? How you figure this out, it depends totally on what's happening to x. Are the x's going up at the same amount? Equal increments. Yep, all good. Look at the y's. What's happening to the y's?
Increase by 1
Every iteration, okay, so it goes, the first one goes up by 1, and then by 2, and then by 3, and then by 4. That's called linear growth. And when your rates of change are linear, you have a quadratic. You could also do the second differences, and they're all 1, and when the second differences are constant, you have a quadratic. Perfect. All right, what's happening in B, or the second one? It looks like we're multiplying by 4. And since we're, but what? Oh, okay, stop. To answer the question, the x's are all growing at the same rate. So we can go ahead and say this is exponential because the outputs are proportional. They are increasing by the same number. Now, the number isn't 4. If I were gonna write this equation, 4 would not be my b, right? 4 would not be my b. How come? Because each x is in steps of 2, right? But we're not writing the equation here, we are simply figuring out if it's exponential. So would you agree it's exponential? Everybody okay with that?
And recently you just said like multiplying AOC by 4.
I would say the outputs are proportional. Because if you take output 2 divided by output 1, output 3 divided by output 2, the ratio is the same. All right, number 5. Little word problem. Some of us are struggling with those in our homework. Just take a minute, see if we can figure out what's going on in number 5. Sure. Do it up there, you got an answer, put it up there. Show us your work too. You see how you figured it out.
You got that.
I'm not telling you what I got. What's the worst that can happen? You'll make a mistake.
On video.
You know how many of those I make every day? Then that random guy will send me and make a comment. I would have done the problem this way. Okay,
Who's even watching?
I know. Somebody with obviously no life.
Wow. Did not expecting that.
Ben read that.
No, you got it.
We have 8 minutes of class left. Is it an emergency?
No, okay.
Okay.
It's actually kind of like.
One, yeah, rigged, called rigged it. One, thing that's important to keep in mind is, based on 2 data points, which is all you were given, you cannot make any conclusion, whether it's arithmetic or geometric. That's why he's very careful to tell you when he writes the problem, this is geometric, right?
Yeah.
Yeah, no, yeah, you could, I'm just making that point, because we need to make sure we have more than 2 points if we have to decide on our own. She got 320,000. I see some nodding. Charisse is nodding.
Take the nine.
Yeah.
So she said I gotta go from the 3rd to the 6th. That's 3 steps. I need to multiply 3 times. That's R cubed, R. In getting from 2,500 to 20,000, that is a multiplication of 8. 8. I have to get a total multiplication of 8 done in 3 equal steps. So each step is times 2. So she formulated it, which is fine. What I did was just say, okay, I know R is 2. I have to get from the 6th to the 10th, which means I have to multiply by my R 4 times. So I just took 20,000 times 16. She actually formulated it for you, but that's all I did. I just wrote it like that. And I got 320,000. Perfect. All right, let's do one more. Let's do number 6. The first 2 are easy. You got a picture right in front of you. So the limit to negative infinity is what? This is problem A. 0 from the bottom. And to positive infinity is negative infinity. All right. We're getting low on time, so I'm going to cheat a little bit. So B, the limit will be on the left. The limit is positive infinity, and on the right, it's 0 from the top. Now, what about C? What does C look like? Well, I've told you before, I mean, I do what works for me, you do what works for you. I always look at the base first. That is decay. But with the negative in front, it flips it over, so it's gonna look like that. So on the left, negative infinity. On the right, 0 from the bottom. Right? And we're using our formal notation, but we're running out of time, so. All right, and then we have this guy. Now, we can't have this conversation with that. That has to go. So what does a negative exponent do? Flips it over. So this is 1/5 times 1/4 to the x. Now 1/4 to the x is the k. Putting any positive number in front of it doesn't change that shape. So on the left, positive infinity. On the right, 0 from the top. Does that make sense to everybody? Alrighty. We'll pick up here next time. And, go over homework and whatever else you need to do. Let's get ready for prayer.
I don't know, to me it seems like you enjoy